It's Louie McCurley here again, responding to questions and clarifications about the ANSI Z459 standard. The ANSI Z459.1 standard was recently published as part of the ANSI Z459 Fall Protection Code, and as it's the first standard of its kind here in the United States, there's been a lot of questions about it. There are still some pretty big generalities that I'd like to eventually talk about, and I have been posting things from time to time over the last week or so, but it seems that there are some very specific myths that are being generated about some of the details of the standards. So I'd like to take this opportunity today to kind of talk about one of those specifics that keeps coming up. So today we'll be talking about the idea of attaching two descenders to a single connection point on your harness, with the idea that by having two identical systems, one of those systems would serve as a primary and the other as a backup. Now, before we start, I want to clarify, this is not an official standards interpretation. I am posting this information of my own accord based on my 35 years or so of experience in rope access and work at height, including having participated as a member of several standards committees and as chairman of the initial ANSI Z459.1 standard. And I was also founder of the Society of Professional Rope Access Technicians, or SPRAT, and my day job is I work for PMI. So I'm coming at this from a perspective of a variety of experience, not from the official standpoint of ANSI or OSHA or the American Society of Safety Engineers. So, first, to clarify, this is what a typical rope access system looks like. You have a progress system and you have a backup system. So the progress system might consist of a descender like this one, or it might involve an ascending system with a chest ascender like this and a handle descender like this, or some combination of those. But the idea is that the progress system would be on one rope, and then the secondary system would be on a separate rope. Now, the secondary system, we call it a backup system, and that's comprised of a rope grab of some sort with whatever sort of cow's tail or rope access lanyard is approved to go with it. Now, what specific components of equipment you choose, the brands and models, if you will, those might vary. And today, I'm going to be using just a plethora of different brands of everything except for rope, of course, but I'll be using a plethora of different brands of components just to make that point, that it's not about which model or brand of descender or ascender or backup device that you use. The main concept remains that there's a progress system, and that's attached to your ventral or waist attachment, and there's a backup system, and that's attached to your sternal attachment. This is rope access. So with that as a beginning point, this type of typical rope access system with a progress system at the ventral and a backup system at the sternal, that's the only type of system that is addressed by the ANSI Z459.1 standard. Now, there might be different kinds of systems that you use that aren't typical rope access systems, but those are not addressed by the standard. For example, the ANSI Z459.1 standard does not address conventional fall arrest. It doesn't address restraint. It doesn't address the use of netting systems for catching falls. It doesn't address that thing that people call RDS, which stands for rope descent systems. The ANSI Z459 standard just doesn't address any of those things because they are not typical rope access systems. Doesn't mean that they don't get used. It just means that this standard doesn't address them. So in a typical rope access system, this is how we do it. We have a primary system for progress on the rope, and we have a secondary or backup system, and they are attached to two separate attachment points on the harness. The progress system typically being down here at the ventral, and the backup system or the rope access backup system typically being here at the sternal. Now, in fact, there's a paragraph in the standard that clarifies exactly what type of system this ANSI Z459 standard is addressing. Paragraph 3.2.2 says specifically, in order to be considered rope access under this standard, there must always be two frontally attached systems in place, a progress system and a rope access safety backup system. And that in order to be considered rope access under this standard, the two must be interchangeable. In other words, I've got to be able to take off the equipment from my progress line and switch it to my backup line. And my backup stuff has to be able to come off of my backup line and be put on my progress line so that the two are interchangeable. That's part of what makes it called rope access. Now again, rope access is not the only way to work on rope. This is just what makes it rope access. So that's what this standard considers to be rope access. If you're doing something else that's not addressed by this standard, it doesn't invalidate it or make it illegal to use. It just means that it's not recognized as a typical rope access system by this standard. Now, there appears to be some heartburn with another paragraph in this section that talks about not simultaneously loading the same attachment point. Now, by simultaneously loading the same attachment point, here's kind of what I'm talking about. That paragraph in Z459 reads, it's paragraph 3.2.2, and it reads, and I'm going to read it here. It says, the rope access safety backup systems and the rope access progress systems shall be attached to the rope access technician's harness in a manner that avoids both the progress system and the rope access safety backup system simultaneously loading the same attachment point. So the standard goes on to say in a note something along the lines of this doesn't mean that multiple attachments can't be simultaneously made to the same attachment point. Gosh, we do that all the time in rope access, especially during transitions, such as at a re-anchor or a rope-to-rope transfer. Simultaneous attachments to the same point on the harness, and the standard says this in a note, simultaneous attachments to the same point on the harness are essential to prevent swing fall and protect the worker. The intent in the standard is that the progress system and the rope access safety backup system should not be simultaneously loaded on the same point. Why on earth would a standard like that be, or would a statement like that be in the standard? Well, I'll tell you. This paragraph was written specifically to address a couple of requirements that are actually found in OSHA regulation. Now, specifically, OSHA has, as you probably know, two segments. They have the General Industry 1910 and Construction 1926. And 1910-140, paragraph C, paragraph 10, and 1926-502, paragraph D, paragraph 6, both say essentially the same thing. And that is that two connectors are not permitted to be attached to the same D-ring at the same time. Now, let me be clear. These are OSHA regulations that say this. OSHA, as you might recall from an earlier post, carries the weight of law. All we're writing in ANSI are standards. So OSHA is law. ANSI can't write standards that conflict with law. Makes sense, right? So we knew from the get-go that this was going to be a bit of an issue in rope access, right? Because I'm going to grab a second set of ropes here. In rope access, we frequently attach two completely separate systems, mirrored systems of one another. We often attach two completely separate systems that look identical because when we're doing changeovers for whatever reason, such as rope-to-rope transfers, typically this is what keeps us from entering a swing fall hazard. So having these two progress systems at our disposal to play off of one another and two backup systems, both on our sternal attachment, they protect against the swing fall potential as we move from one set of ropes over to the other set of ropes. So that's the absolute safest way to do it. But then there's this thing where OSHA says two connectors can't be attached to the same D-ring. So in the development of the standard, we ran into this as a sticking point because taken at face value, certain methods that are essential to rope access, particularly those involving changeovers and rope-to-rope transfers, they simply wouldn't be allowed at all under what the OSHA regulations seem to say. So ANSI can't very well write a standard that's in conflict with a regulation, can it? So do we just bag rope access? Well, that wasn't our goal. So we conferred with regulatory representatives, fall protection engineers, system designers, qualified persons to try to figure out what OSHA's intent and concern was with this matter of connecting two attachment points or two connectors to a single attachment point simultaneously. And here's what we learned. We found out that there was a specific concern with compatibility and rollout. So when you jam multiple connectors into the same connection point, there's a concern that they can sometimes prevent each other from working properly. They can sometimes prevent each other from, they can work in conflict with one another. And even when they do work, when you load any point from multiple directions simultaneously, it can create greater stresses on that point, often in directions that point was never intended to be loaded. So we addressed these particular concerns in the Z459 standard by calling out compatibility. We specified in paragraph 5.3.1 that the manufacturer needs to address compatibility in product instructions. And then in paragraph 7.2.2, where it says that authorized technicians must be knowledgeable on this topic. So those two things then work together. That the manufacturer provides the information that the technician needs, and then the technician takes responsibility for being educated in that regard. And we address this matter of compatibility. So then the other concern that we identified had to do with redundancy. So many of the fall protection experts that contributed to the process, including some regulators, asserted that a system is really not fully redundant if both the primary and the secondary systems are simultaneously loading the same point. So, again, this isn't something that we do a lot, but still, the point is that the redundancy would be lacking for the primary and secondary system. So let's clarify redundancy. Redundancy can essentially be defined as the idea that the failure of any one point will not result in catastrophic failure. I'm going to repeat that. So redundancy can essentially be identified or defined as the idea that the failure of any one point will not result in catastrophic failure. But here, when you have both your primary, and in this case, I would be connecting my other system. In fact, let's just attach my progress system to my backup system. Now, if both of these were loaded at the same time, I would be in violation of OSHA regulation, because if they were loaded at the same time, failure of this point could conceivably result in catastrophic failure. Now, whether that's probable or likely or not, where does, you're one technician, you're wearing one harness, where does this concept of redundancy begin and end? Yeah, that's a thing for sure. But where OSHA has decided to draw the line is at the connection to one point. There's kind of no getting around it. OSHA says what they say, and regardless of how you or I might feel about it, it's a thing. In fact, it's a regulation, meaning it carries the weight of law. So the consensus group, the ANSI Z459 standards group, writing this Z459 standard, concluded that we needed to meet the intent of the OSHA regulation in terms of redundancy. So the committee worked within these parameters, and we provided that paragraph that I read earlier, 3.2.2, to give context to what we had learned about how the larger body of fall protection experts interpret OSHA's rule, so that both users and regulators would be clear on the concept that it's actually okay to put two connectors into the same attachment point, but that we're not to simultaneously load one point with the primary and the secondary systems at the same time. If you do that, you would be out of context of the Z459 standard. And incidentally, perhaps more importantly, you would also be in violation of OSHA regulation, which should probably really be your primary concern. So that's one of the things that has been brought up as a concern in this whole process. Now, I'm going to bring up something else that I originally wasn't going to talk about, but because it keeps coming up, I'm going to go ahead and address it, just because we're here, and I've got a bunch of gear out, and so we might as well talk about it now. So let me talk about this concept of twin tension rope systems, or dual tension systems, or mirrored systems. People call them by different names, but Essentially, the premise is that by creating or by attaching two descenders to the same point and using those simultaneously, and normally you'd use two identical descenders, but I was trying to make the point that specific brands don't matter, so I don't have identical descenders, but normally you'd use two identical descenders on the same point. And by using that, you can create a I guess a redundant system with each of the ropes taking more or less half the force. One is essentially backing up the other. So the concept actually comes from the rescue world. This is the way that we did rescue 30 years ago or more. And we would anchor a descender to a structural anchorage, and then we would anchor another descender to the same structural anchorage, and then we would operate both descenders simultaneously so that, in effect, one would serve as primary and the other as backup, although, you know, they're kind of in tandem. So that system took a lot of flack. For a long time, it was actually considered bad in rescue because there were arguments about whether or not it really provides redundancy in a rock fall or other slicing over an edge incident or something like that. You know, those two ropes are so close together that they're not really redundant. If this single point, the anchorage would fail, then that would be a problem and it would not be redundant. But then a few years ago, somebody was like, oh, wait a minute. In the event that just one of these systems does fail, there's going to be less shock load on the other system because it's already under tension. So maybe there's something to that. So this twin tension system kind of came back into vogue in rescue. And because rope users are rope users and they tend to do more than just one thing, rescuers are rope access technicians become rescuers, so on and so forth. The concept is leaking over into rope access. But in this case, the idea is that instead of anchoring the two descenders to an anchorage, you would connect them to your harness. So, and then you would operate both simultaneously. Now, the place that most people are most promoting this system is for long drops, like when you have 600 feet of rope out, especially if you're using the European style of low stretch rope, because you're that rope has so much stress and stretch, unless you're using really static rope, which isn't acknowledged at all in Europe. But if you're using, if you're not using static rope, if you're using low stretch rope or what Europe refers to as semi-static rope, there can be an enormous amount of inherent stretch in that long system. So proponents of this twin tension stuff, they suggest that two descenders are easier to manage than a single descender with a backup. Now, I'm not going to argue the point one way or the other. I'm just sharing the concern here that's been expressed to me about the Z459.1 standard. I'm not going to comment at this time on the efficacy or the appropriateness or the need for this type of system. Maybe we can have a debate in another post about that. But for the time being, I'm going to focus on the assertion that the Z459.1 standard disallows this kind of system. And that concern has been presented a number of times. So let me be clear. As I said at the beginning of this presentation, the twin tension system that I just described to you is not a typical rope access system. Most rope access that employers engage in is the typical kind that we already talked about, not with two descenders to the same point. Go away, rope. But with a primary system at your ventral and a backup system on your sternal. That's the typical kind of rope access that we're talking about. So to go back to what I said earlier, standard rope access is all that the ANSI Z459 standard addresses. It does not address twin tension systems at all, because twin tension systems are not a typical rope access system. They are unique. They're used for special circumstances. And when you use them, you have a whole different set of parameters and criteria to keep in mind. Just like when you use conventional fall arrest or restraint or RDS or netting systems, you have different things that you need to take into consideration than when you're using a typical rope access system. So the ANSI Z459 standard just doesn't address any of those because they're not typical rope access systems. So if you're using any of those kinds of systems, you would be working outside of what we consider by the Z459.1 standard to be typical of rope access. and different criteria and regulation would apply. So in the absence of ANSI standards, what regulation would apply to a twin tension system? Well, for that, we need to go back to a post that we did last week about OSHA regulation. In that post, we explained that OSHA has a catch-all category called fall protection. And in that category, there are some big picture, broad-reaching requirements that apply to all fall protection. And then there's more specific criteria for individual systems like fall arrest, rope descent systems, restraint, things like that. So theoretically, your qualified person could specify a system that is different from anything that's already addressed by ANSI or OSHA standards, as long as it follows those overarching requirements that OSHA specifies for fall protection. Things like impact force and deceleration requirements, auto-locking descenders with 3,600-pound gates, prohibition against simultaneous attachments to a single point, requirements for rescue, things like that. Those are OSHA requirements. So if your qualified person wanted to create a different system in compliance with that, they could do that. Now, to be clear, OSHA does allow for alternative procedures of compliance where the employer can prove that a different system will protect workers as well or better than OSHA standards. So there is a variance process. So that's what it's called. It's called a variance. And if you want to delve more into that, you can look up Title 29 of the Code of Federal Regulations, and it's in Part 1905, which is their rules of practice. And there you can learn more about variances. So to summarize here specifically about this fallacy of ANSI Z459 prohibiting the use of two connectors to a single point. First, OSHA regulation has mandated for decades that two connectors are not permitted to be connected to a single attachment point in any fall protection unless the equipment is specifically designed for that purpose. ANSI standards are not permitted to be any less stringent than OSHA regulation. So the paragraph found in ANSI Z459.1 about this was actually designed to do you a favor. It was designed to provide clarification and allowance for doing things like to rope transfers safely and efficiently while still maintaining compliance with the extended provision of the existing OSHA regulations. So OSHA regulation, you're still following OSHA regulation, but here's kind of how it's applied in terms of rope access. And then finally, I want to clarify again that twin tension systems are not addressed by Z459 because they are not a typical rope access system. If you want to use a twin tension system, your qualified person can address that in context of OSHA regulation and whatever parameters you need to follow. So that's a lot. This has kind of been a long one. We've covered a lot today. I hope that it's helped to clear up at least this one point that's been so misinterpreted by so many regarding the Z459.1 standard. If you're an employer or a regulator, I highly recommend that you get a copy of the standard yourself and read it to see how it can help you provide greater safety in work at height. And if you have any questions, please do continue to share them with me. My name is Louie McCurley. Although I was chairman of the inaugural ANSI Z459.1 standard, I am not speaking officially on behalf of ANSI, nor on behalf of the American Society of Safety Professionals here. This post is simply to provide context and perspective on the development of the standard as it was written and what it says from the perspective of somebody who was there during the process. If you wish to have an official interpretation, you can always reach out to the ANSI Z359 committee for that. They are overseen by the American Society of Safety Professionals, and I would highly encourage you to do that. So, again, please do continue to contact me with specific questions and concerns because you're the ones providing content for these posts. My goal is to address as much as possible in a public forum for the benefit of everybody who's doing rope access. So, stay well and stay safe and keep in touch. Thanks.